Now that we know about the binomial coefficients, we're going to proceed to expand our first bracket, so x plus y to the power of 6. Now, the first thing then is, what are the coefficients going to be? So we're going to have, well, the power of the bracket is 6, so we're going to start off with 6, 0, and then we'll have 6, 1, and then 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6. So those are the coefficients, which we'll simplify in 1 minute. What happens next? Well, we're going to have the first term as x to the power of 6 and y to the 0. We reduce the power of x by 1 and increase the power of y by 1, so x to the power of 5, y to the 1, x to the power of 4, y squared, x to the power of 3, y cubed, x to the power of 2, y to the power of 4, x to the power of 1, y to the power of 5, and x to the power of 0, y to the power of 6. We don't have to worry about any negative terms in the bracket, so we're going to have a plus in all of these terms. So that's it, expanded, but we need to simplify. Now remember, the first and last terms on the Pascal's triangle are a 1. So we're going to have 1, 1x to the 6, and we'll just write that as x to the power of 6. The next term is going to be a 6, x to the 5y, plus, use your calculator to get the next coefficient, so it's 6, choose 2, that gives us 15, x to the 4y squared, 6 choose 3 is 20, x cubed, y cubed, then we're going to have 15 again, x squared y to the 4, and the last two terms, so this is going to be a 6x y to the power of 5 plus 1 y to the power of 6. Second example, we have coefficients to deal with, so 2a minus 3b, and we also have the negative sign to deal with, and that's to the power of 3. This is one taken from the textbook. So we've got to be careful about these coefficients and about the negative signs. What I'm going to do is I'm going to write this as 2a plus minus 3b to the power of 3. So the power isn't too high because there are other things to think about. So let's get the binomial coefficient. It's going to be 3, 0, and then 3, 1, 3, 2, and then 3, 3. So first term is going to be 2a to the power of 3 minus 3b to the power of 0 plus. Now reduce the power of the first term by 1, so 2a to the power of 2. You'll notice that the 2 is going inside the bracket with the a, and the minus 3 is going inside the bracket with the b. That's very important. Then minus 3b to the power of 1 plus 2a to the power of 1 minus 3b to the power of 2 plus 2a to the power of 0. You might in fact want to leave out the terms which are to the power of 0. I'm putting them in to make it clear what's going on. 3b minus 3b to the power of 3. So simplify. 3 choose 0 is 1. Now 2 to the power of 3. 2 to the power of 3 is 8, so we have 8a cubed minus 3b to the power of 0 is 1 plus, so 3 choose 1 is 3, 2 squared is 4, so that's 4a squared, and it's minus 3b to the power of 1, so we better need to keep the negative in there. Minus 3 to the power of 1 is minus 3, plus 3 choose 2 is 3, 2a to the power of 1 is 2a, minus 3b all squared, well minus 3 squared is 9, so it's 9b squared, and the last term, 3 choose 3 is 1, 2a to the power of 0, all to the power of 0 is 1. Now minus 3 cubed is minus 27, b cubed. And what we need to do then is to simplify that. So this is what we've got. If we simplify it, we get 8a cubed. Now 3 times 4 is 12, times minus 3, that's minus 36. A squared, b. 3 times 2 is 6, 6 9s are 54, plus 54, a, b squared, minus 27, b cubed. Example 3 asks us to find the fourth term of bracket 3 plus a to the power of 8. What I'm going to do now is talk about something called the general term. It's a formula that we can use in a question of this sort and in harder questions. So, what does it look like? Well, we know that the binomial coefficient is going to be 8 something. 8 choose r. Now remember, this is a general term. We don't have the value of r yet, but we can choose it, and we will choose it in a minute. So it's 8 choose r. The first term is 3, so it's going to be 3 to the power of 8 minus r. And the second term is a to the power of r. That in fact is the general term for this expansion. So what does it say? We want the fourth term. Well, for the fourth term means that r has what value? Well, we start counting with r equals 0. So the first term is r equals 0, 1, 2, 3. The fourth term is when r has the value 3. Now that we have a general term, we can substitute r equals 3 in, so it's going to, the coefficient of the term is going to be 8, choose 3, 3 to the power of 8 take away 3, and a to the power of 3. Now, calculators, 8, choose 3, gives us 56. That's 3 to the power of 5. That's 243. And then a cubed. And that's 13608 a cubed. And that saves us having to write out all the terms, working with the general term. Example 4, so we want to evaluate the term in x to the power of 7 and the expansion of 1 plus x all to the power of 10. So what I'm not going to do is to expand this whole bracket. I'm going to work out the general term. So the binomial coefficient will be 10 choose r. R is a number that we're going to have to find. The first term is a 1, that's nice and easy to deal with. 1 to the power of 10, take away r. And the second term is x to the power of r. This is actually quite a simple question. If we want x to the power of 7, it means that R must have the value 7. So substituting that straight in, we have 10, choose 7, 1 to the power of 10 minus 7, and x to the power of 7. Calculators, 10, choose 7, gives us 120. 1 to the power of anything is 1, x to the power of 7, so it's 120, x to the power of 7. Final example, expand 1 minus x plus y all to the power of 3. Now the first problem is that we have 3 terms in here, that's not a binomial. The second problem is that we have a negative between the 1 and the x. Now how are we going to deal with this? I'm going to rewrite this whole bracket as 1 plus, I'm going to move the minus x after the y. I'm going to put the y and the minus x in a bracket to the power of 3. Here is now my first term, and I'm going to take that all as my second term. So proceeding, we have binomial coefficients. It's going to be 3, 0, 3, 1, 3, 2, and 3, 3. We've got 1 to the power of 3, 1 to the power of 2, 1 to the power of 1, and 1 to the power of 0. We've then got y minus x to the power of 0, y minus x to the power of 1, y minus x to the power of 2, and y minus x to the power of 3, plus, plus, and plus. So this whole first term is just 1. 3 choose 1 is 3. 1 to the squared is, well, all of these terms here, powers of 1, just give us 1. So we just then have 3 lots of y minus x. 3 y minus x all squared plus y minus x all cubed. That's 1 plus 3y minus 3x. We can now expand the brackets, plus 3. Well, we can expand some of the brackets. That's going to be 3 lots of y squared minus 2xy plus y squared plus we have y minus x cubed. So if we use our knowledge of the binomial theorem, the coefficients are going to be 1, 3, 3, 1. So it's going to be 1 y to the power of 3 plus 3 y squared times minus x plus 3 y to the 1 minus x squared plus 1 lot of minus x to the power of 3. That's y cubed minus 3x y squared plus 3x squared y minus x cubed. So if we go back to our original, 1 minus x plus y to the power of 3 equals 1 plus 3y minus 3x plus 3y squared minus 6xy plus 3y squared plus all of these terms here. So y cubed minus 3xy squared plus 3x squared y minus x cubed. Now if you look closely at these terms, you can see, I think, that the only two that are alike are these two terms here. Those are the only two that will go together. So if we simplify, we get 1 plus 3y minus 3x plus 6y squared minus 6xy plus y cubed minus 3xy squared plus 3x squared y minus x cubed.